right, today we're going to talk about 9.2 special right triangles. We're going to talk about two different types of special right triangles, and that's really all you have. So your essential question is, what is the relationship among the side lengths of a 45 degree, 45 degree, 90 degree triangle? And then the same question, what is the relationship among the side lengths of a 30 degree, 60 degree, 90 degree triangle? And this is really just something that you should have memorized. You're going to memorize this. You're going to use this basically for as long as you're doing math, or even sometimes building things, doing things where you do need to use a bit of right triangle trigonometry or right triangle geometry. Okay, so the first triangle we're going to talk about is a 45 degree, 45 degree, 90 degree triangle. So I'm going to go ahead and draw one. Let's see, I better use a ruler. All right, so I have a right triangle, that's the 90 degrees. And then the other two angles are 45 degrees. So hopefully right now to yourself you're saying, oh, well then this is an isosceles triangle because these two angles are the same. So base angles are the same. So then the legs opposite them are going to be the same. So I've got an isosceles triangle. I'll go ahead and mark that with some tick marks. So then that means that I can basically label them both. I'll label them both A. Well then how do I find the hypotenuse? Okay, well the hypotenuse, now this is a special right triangle, so this is always the case. The hypotenuse is equal to either of the legs times the square root of 2. So in our example here, our hypotenuse will be A times the square root of 2. Okay, so this is very key. This is going to be equation that maybe we'll use often to help us try and solve for either the hypotenuse or the leg when we're given one or the other. I'm going to go ahead and highlight that. All right, and then this is our 45, 45, 90 triangle. Okay, and then the other special right triangle is a 30 degree, 60 degree, 90 degree triangle. And I'm going to do the same thing. I'm going to go ahead and draw it, trying to draw it accurately to the best of my ability. So in this one, we don't have congruent legs, so one of them will be longer and one of them will be shorter. So I'm trying to make that triangle look like that. This is a 90-degree angle. So my longer leg is here, so the angle opposite it should be the bigger angle, which is 60 degrees. And then this is my shorter, so we'll call this our 30 degrees because it should be the smaller angle. Okay, so we always start with the short leg. So we've got a short leg. We've got a long leg. Oops, not a log leg, a long leg. And then we have a hypotenuse, of course, right? Now there's a special relationship that is always the same. So I always start with the short leg, and I'm going to call that A. And then my long leg is root 3 times that, so A times root 3. And my hypotenuse is also related to my short leg. My hypotenuse is 2A. So in words, we would say that hypotenuse is equal to 2 times the short leg. The other relationship is the long leg, and that's equal to root 3 times the short leg. So notice for both of these, you need to know the short leg in order to get them. So everything's dependent on the short leg. Now, if you're given the hypotenuse, it's just a very simple equation to figure out the short leg. Take the hypotenuse, divide by 2, right? We just solve for short leg. So these are the two key equations for figuring out missing lengths of sides, whether it be hypotenuse or legs. And this is for the 30, 60, 90. And those are your two special right triangles. Okay, so we're going to practice this. Now, for this year, I expect you guys to write out these equations. These are equations. You fill in what you know. You solve for what you don't know. Okay, so I expect to see this in your work. I expect to see these written out. You write them enough times, eventually, through repetition, they just become habit, and you learn them quite quickly. Okay, so let's do some examples here. So, example 1, we're going to find x. So, for the first one, we'll do a. I'm not going to be so exact anymore with my triangles, because now it doesn't really matter. They're just problems. Okay, so 22, 22, I got a right angle. I need to figure out x. Now, so you should look at this and you should say to yourself, look, I've got an isosceles triangle. It's a right triangle, which makes this a 45, 45, 90. This is a special right triangle. And I know that the hypotenuse is always equal to the leg times root 2. So what I'm saying when you do your work is write that out. And you can abbreviate. Hypotenuse is equal to either of the legs times root 2. Well, my hypotenuse here is x. My leg is 22 times root 2. So there it is. I figured it out. That one was actually pretty quick. Pretty quick, pretty easy. Okay, cool. So let's do another one like that. Okay, so for B, I'm going to do a right triangle kind of on its side. Okay, so I'm going to have my two legs are both going to be x. My hypotenuse is going to be 2. So I look at this and I say to myself, my two legs are the same. Therefore, I have an isosceles triangle, and it's a right triangle. So this has to be a 45, 45, 90-degree triangle. So then I know that the relationship is that the hypotenuse is equal to the leg times root 2. So I'm going to use that equation, plug in everything that I know, solve for x. So I know that my hypotenuse is 2, my leg is x, root 2. Or in other words, to figure out my leg, I have to divide both sides by root 2. So I get x equals 2 over root 2. Now, this is not an okay answer. It's not completely simplified. There will be times where you'll see an answer given like this, and there will be times where you won't. And so we have to be able to recognize this is one of the answers, but it's not completely simplified because we have a radical in the denominator. So that means that I have to rationalize the denominator. So I'm going to multiply top and bottom by root 2, because by doing that, root 2 times root 2 now is just 2. So x is actually 2 root 2 over 2. And then these 2's reduce, so x is really just root 2. For example 2, we're going to do a problem that says find x and y. And we're going to use a right triangle. Where I have a longer leg and a shorter leg. My hypotenuse is 30. My shorter leg is y. And my longer leg is x. So then the bigger angle will always have to be across from the longer leg. And that's my 60-degree angle. And then across from the shorter leg should be a smaller angle. We'll go 30 degrees. So you can see that I'm giving you an example with a 30, 60, 90-degree triangle. And you don't know either of the legs, but you do know the hypotenuse. So I'm going to look for a relationship that involves hypotenuse. Hypotenuse is equal to 2 times the short leg. So I'll write that out real quick. Hypotenuse equals 2 times, and if you just want to write short, you totally can. Okay, so my hypotenuse right now is 30. 2 times, and then my short leg is y. So to solve for y, I just divide both sides by 2. I get y equals 15. Okay, and then I should also work on figuring out then my longer leg, my x, right? And the relationship for that is that long leg is equal to √3 times short leg. Or I'll go ahead and write it like long equals √3 times short. Okay, so I'm going to go ahead and fill in the fact that I already know my short leg. That might help us a bit, right? So my long leg is x. I don't know what that is. But I'm going to do √3 times my short leg, which is 15. Or in other words, my long leg is equal to 15 √3. We usually put the the whole number in front, and then the radical goes next. So those would be my two answers. Pretty easy. Hopefully you're finding this pretty easy, and you're going to get a lot of opportunity to practice. And again, I'd like you to be writing out these equations. And then after this assignment, you won't have to do that anymore. And you'll hopefully have it committed to memory. Also in the classroom, I do have this information. This is on a poster above one of the whiteboards. So it's usually up there for you to look at. You just have to know how to use them. Okay, and then we're going to do example 3, which is to find the area. You've been doing problems like this. All right, so I'm going to give us a triangle. Let's see, I'll try and make my picture nice because we're going to have to do some work with this. Okay, you are given that these two sides are 4 feet, 4 feet. Oh, actually, all sides are 4 feet. Sorry, you're given all 3 sides are 4 feet. So what kind of a triangle is that? Well, that is a triangle. That is that's an equilateral triangle, right? All sides are congruent. So therefore, what else is all congruent? All angles are congruent. So that tells me that each one of these angles is 60 degrees. Okay, so you always want to be thinking about these things because I haven't been given much information here. In order to find the area of a triangle, it's 1/2 base times height. And height is always perpendicular to the base. So do I actually have a value for the height? This 4 right here, we call that a slant height. We'll talk about that later. That's more 3-dimensional figures. But I don't have a height. I'm going to go ahead and draw a height, and I'll just make it a dotted line. I'll call that H. Still don't have a height. This isn't helping me very much, right? Okay, so I know that each angle is 60 degrees. I'm going to take out of this just a smaller, just half of this, just one of those right triangles. It doesn't look anything like it, but just imagine. So we know that this is 60 degrees. Now, it's an equilateral triangle, and I'm dividing it in half, right? So these two triangles here are going to be congruent to each other, if by nothing else, angle, angle, side, or hypotenuse, leg, okay? So that tells me that my base here, now in this half of this, is going to be 2. Height, I still don't know. Hypotenuse, though, I do know. This is a 60 degree, and if I divide this in half, this was also 60 degrees, but just half of it's going to be 30 degrees. So that tells me that this is a 30-degree angle. Okay, so I should be able to find the height here, given the information that I've been given, right? So H is my long leg, and I do in fact know my short leg, and I know that the relationship is that my long leg is going to equal √3 times my short leg. Okay, so my long leg is H equals √3 times, and then my short leg is 2. Okay, so H is equal to 2 √3. So that's my height. So now I can go back and I can find the area of this, which is basically just plugging everything that I have now. 1/2, my base is 4, and my height is 2 root 3. Now, I like to simplify before I multiply. These are both over 1s. So I'm going to just reduce these 2's. They become 1s. And the area here is going to be 4 root 3. And we'll say, because we were given units, this should be square feet. Okay, so this is the most exact answer. Now, some of you might get on a calculator and give an approximation. I'd like to see exact answers unless it says round to the nearest. However, in the back of the book, it might be a decimal. So you're going to have to know, hey, is that the same thing? And so I'll just go 4 square root of 3 is about 6.928. So you could give it like this as well. And you'll need to know that in case what if that's the answer in the back of the book? Just know that this is the most exact answer. I prefer the answers look like this.